Hi everyone, I'm going to show you guys of how to find the center of mass of this sector using integration. So the formula to find the center of mass is this, right? So this is the formula to find the center of mass for a sector. So in this case, you can see the angle is 90. Alpha is going to be 90 divided by 2, right? So this is straightforward, but I'm going to show you guys of how to find the center of mass using integration. So the basic formula to find center of mass using integration is this: center of mass along the x-axis. As you can see, it's perfectly symmetrical. We don't have to worry about the center of mass along y-axis. We only have to worry about the center of mass along the x-axis because it's going to be somewhere here, and we need to find that point. So it's the center of mass along x-axis equals 1 over the area and the intervals x into fx dot dx, right? This is the formula. But I'm going to show you a different approach to this question. As you can see, this is a polar coordinate question, right? Polar coordinate questions always start with r. So it's not fx, it's actually r, right? It's going to be r equals either sine theta, cos theta, phi cos theta. It can be anything for an example, right? So I'm going to do it like this. So I'll write the center of mass equals... No, first, let's find the area first. So how do you find the area? So we use the formula half into r squared theta. And when you substitute theta, it should always be in radians when using this formula, okay? When using this formula, you always substitute the radian angle. So half into r squared into... So this angle is 90, right? So what's 90 in radians? It's pi over 2. So that giving you r squared pi over 4. This is your area. We can leave that aside for now. So the center of mass equals 1 over a into the integration of... It's not going to be x though. Now, it's only going to be x into fx if our graph was either a line, a curve, something like that. Y in terms of x. But in this case, we have a radius, right? This is like a section of a circle. So we are going to consider polar coordinates. So when considering polar coordinates, instead of x, it's going to be r, right? So r into fx dot dx. So I'll show you what we take for fx. So what I'm going to show you guys is if I draw a straight line from here and I take this as y, because that's the y direction, right? You can take it as y. And if I take this as theta, can you see sine theta equals opposite side, which is y, over the hypotenuse, which is r. So y equals r sine theta, right? So this is going to be... Oh, and here it's going to be dr. Yeah, sorry about that. I put dx, it should be dr. So 1 over the area and integration of r into... So fx, which is... So fx is y, right? So what I got previously was sine theta equals y over r, right? So y equals r sine theta. Looks like I erased it previously. So we're going to put r sine theta dot d, right? And your area is r squared pi over 4. We can put that in now. We can take sine theta outside because we have to integrate. Sine theta is going to be a constant, right? So because we are going to integrate r squared. So what's the integral of r squared? That is r to the power 3 over 3, right? So into sine theta. And when you take the reciprocal, it's going to be 4 over r squared pi. Let me just write it again properly. Okay, so this is your center of mass. You can cancel this off and you get 4 over 3 pi sine theta, right? So now we know the angle, right? And we have a range. We have a range from... So below the x-axis, when you go clockwise, this is negative 45, right? And this way, it's positive 45, right? according to the Cartesian plane, when you go anti-clockwise, it's positive, and when you go clockwise, it's negative. So we're going to substitute the range. So 4 over 3 pi into sine theta pi over 4 and negative pi over 4. This giving you 4 over 3 pi into sine pi over 4 is root 2 over 2, right? Minus root 2 over 2. So it's 4 over 3 pi into, so it's gonna be plus, right? So that's root 2. So you'll find out, oh wait, did I forget r? Oh shit, there was an r in here, right? Because when you divide r to the power 3 by r squared, there's gonna be r here. I forgot that, I'm sorry about that. So yeah, there's an r over here. So it's 4 root 2 r over 3 pi. This is your center of mass for this sector. We can confirm this using the general formula 2r sine alpha over 3 alpha. So 2r into sine alpha. So I told you guys previously, alpha is going to be half of the total, right? So which is sine 45. Sine 45 over 3 into sine 45 is pi over 4, right? So sine 45 is root 2 over 2. Root 2 over 2 into 3 into pi over 4. You can cancel off 2 and 4 comes up. It's going to be 4 root 2 r over 3 pi, right? Same exact thing. So therefore, the answer I got is correct. So this is how you do it using integration. So if you guys have any doubts, please drop them in the comment section. And I'll make a separate video as a short proving of the formula for proving the formula to find the center of mass of a sector. So yeah, if you guys like my teaching, leave a like and subscribe. Have a great day. Thank you so much.